Hello everyone, my name is Chad Smith and I'm a Technical Alliance Architect here at Teradici. I want to give you a quick and brief overview of setting up an application load balancer in AWS. This is to distribute peace over IP sessions for both cloud access connectors as well as connection manager / security gateway. Load balancing sessions is an important component in addressing scalability and redundancy within an environment. This guide is not intended to be an exhaustive explanation on how to configure brokering services, rather focusing specifically on AWS load balancers as a part of an overall solution. For the rest of this presentation, I'll be referring to Cloud Access Connector, which is used with our first-party broker as CAC, as well as I'll be referring to Connection Manager / Security Gateway, which is primarily used for third-party brokers as CMSG. Before we dive into setting up a load balancer, I want to review the prerequisites that is needed. First, at least one CAC or CMSG instance needs to be available in a public subnet. Second, a broker such as LeoStream or our own CAS manager needs to be configured as well. Third, two public subnets and two separate AZs within a region needed to be defined within AWS. Fourth, a certificate for HTTPS, either verified or public, has to be available in the AWS Certificate Manager service. Finally, a security group or a collection of security groups with TCP 443, TCP 4172, TCP 6443, as well as UDP 4172 need to be configured as well. Finally, I also thought it might be useful to review the application and session establishment workflow between these various components. When a peace over IP client requests a connection, it makes an HTTP request to the application load balancer. This HTTP traffic traverses the CAC or CMSG broker and finally back to the client itself. Along the way, it gets the user authenticated and also provides a list of entitled instances. The user then selects a peace over IP host and the client establishes a session over TCP 4172 back through the load balancer and to the previously configured CAC or CMSG via a sticky session. The session is initiated on the peace over IP host. It encrypts the pixels and sends the data back through a UDP datagram on port 4172. This UDP traffic traverses the CAC or CMSG through its assigned public IP address outside of the load balancer directly to the peace over IP client itself. Now, let's jump into configuring the load balancing service in AWS. Okay, let's start by logging into the AWS management interface, specifically the EC2 console. You can see that some of the prerequisite instances are already configured and running. We will be load balancing two cloud access connectors that both reside in the same AZ and subnet. I also highly recommend enabling the new EC2 experience in the AWS console as well. It will display a lot of important information, specifically when it comes to load balancers. So now that all the prerequisites have been confirmed, let's set up the load balancer itself. To do so, navigate the bottom left-hand side panel until you reach the load balancer section. Once there, click Load Balancers to enter the console. Next, create a new load balancer. We will be using an application load balancer for this deployment. Select the Create button for the application style of load balancer. In the configuration wizard, enter a name. Keep the rest of the defaults until you get to the listener section. Change it to HTTPS instead of HTTP, and also ensure that port 443 is defaulted. Navigate to the availability zones and ensure you are selecting the correct VPC for your deployment. Note that AWS Load Balancer makes you define at least 2 publicly accessible subnets in at least 2 different AZs within a region. Even if you are only intending on deploying in a single AZ, which we're planning on doing for this deployment, you may have to quickly jump into the AWS VPC services and define an extra subnet, and then jump back into the load balancing wizard to finish this configuration. Once finished, select Next to continue. In the next section, we'll be selecting a certificate for our HTTPS traffic. In a production environment, it's highly advisable to take the extra step of importing a trusted third-party certificate or to purchase one within Amazon itself before continuing in a production deployment. This avoids the piece over IP client throwing a cannot verify connection warning every time it tries to connect. For this deployment, we've only generated a self-signed certificate, so it's the only option that we have available. We also are just taking the default security policies as well. Next, we want to configure the security groups. In the security groups, you can create a new security group, or you can select a predefined one. Remember, you will need HTTPS, TCP 4172, UDP 4172, and TCP 6443 as a part of a security group before you continue. Next, we want to click Routing by creating a target group. In the Target Group section, provide a friendly name to your target group. You also want to ensure that you're using instance as the target type. Also, you want to ensure that you're using HTTPS and it's also using port 443. We also want to ensure that you're using HTTP version 1, and under the health check section, ensure that you selected HTTPS as well, and also set a path for the health check that's /pieceoverip-broker/XML. Click Next to register the targets. To register targets, select the previously configured CAS or CMSGs in the list of available instances. Then click Add to Register to move these instances to the top section of the page. You will see a blue button to select this in the middle of the screen. Click Next to review the screen, and then Create to finish. You will get a message saying that you've successfully created a load balancer. Now, be aware that it does take some time for the AWS load balancing services to be created and start successfully. I'm going to pause this recording for about 10 minutes and then jump back in once everything is created in AWS. In ensuring the load balancing configuration has successfully completed, there are a couple items we need to verify before trying to connect. First, you want to ensure the load balancer service has entered an active state. Second, it's always good to see at least one healthy target available. We can find this information in the Target Group section in the left-hand pane. While we're here, there is one more configuration that needs to be set on our target group as well. To do so, we need to click the Attributes section and then Edit. We want to ensure that the stickiness option is enabled as well. You can take the rest of the defaults, but click OK to set stickiness sessions. Finally, we want to test the load balancer's functionality with a piece over IP client. AWS Load Balancing Service doesn't provide a public IP address. Instead, it provides you a DNS name. This DNS name does take time to propagate through the internet, so it may cause a bit of delay as well. To find this name, go back to the load balancer itself and grab the DNS name from the description tab. If you want to use a more friendly name, simply reserve a Route 53 domain registration and apply the load balancer's ARN to the reserved DNS name. But for now, we'll just use its current DNS name assigned to it. By copying that DNS name, we can enter it on the client in the address or code field. As long as the user has been entitled an instance by the broker, the connection should be successful. Let's minimize the session and take a look at the connection according to the load balancer. If we jump into the monitoring tab, we can see the request count has increased by 1. This concludes our AWS Load Balancer deployment guide for Teradici's piece over IP.